take a look at some more solving trig equations. Remember, these are non-GDC questions, so you cannot use a calculator for these questions, okay? All right, so let's take a look at part A here. So it says to show that 2 cosine squared x plus 5 sine x equals 4 may be written as, all right, 2 sine squared x minus 5 sine x plus 2, okay? So the first thing I recognize is this cosine squared x. I know that I can do a substitution right here to get everything in terms of sine, right? So I have 2, now instead of cosine squared x, I can substitute this with 1 minus sine squared x, right, from our Pythagorean identity, right, plus 5 sine x is equal to 4. So if I distribute the 2, I'll get 2 minus 2 sine squared x plus 5 sine x is equal to 4. And then we need to set the equation equal to 0, so I'll move everything on the left to the right side. So I'll get 0 is equal to 2 sine squared x minus 5 sine x and then plus 2, which is what we're trying to show. Okay? So that's part A. Let's take a look at part B. So part B says, hence solve the equation, right? Now, they want us to solve this equation right here. Since we know that this right here is equivalent to this, right? Instead of writing this right here, right, I can substitute it with this right here. Okay? So basically I have 2 sine squared x minus 5 sine x plus 2, right, is equal to 0. And then all I need to do is factor this. So you can factor this with or without a substitution. I'll just show a substitution just so you guys see. So let's say I make u equal to sine x. So that means that this would be 2u squared minus 5u plus 2 is equal to 0. So if I factor this, I'll get 2u and u minus 2 minus 1. All right, let's double check I factored correctly. This will give me negative 4, negative 1, that's negative 5u, positive 2. So it looks like everything is good. So u is equal to positive 1/2, u is equal to 2. So now that I've solved for u, I can substitute back in the sine x, right? So if I substitute back in the sine x, I'm going to end up with sine x is equal to half, right? And also sine x is equal to 2. Now first one, sine x equals 2, I know this already is undefined because the sine of some angle has to be between negative 1 and 1, our result. So we know this is undefined. So over here, first of all, let's think about our unit circle. Where is sine positive? That's quadrants 1 and 2, right? And then let's go back. What's our interval? Our interval is 0 to 2 pi, so we can go all the way around the circle one time. So the angle from the unit circle that will give us 1/2 for sine, that's going to be pi over 6 over here, and 5 pi over 6 in quadrant 2. Okay? So x is going to equal pi over 6, and x is going to equal 5 pi over 6. Okay? Alright, so let's take a look at this next example here. So this is a really good question, right? Because they're combining logarithms along with solving trig equations. Okay? So let's take a look at part A. So show that log base 9 of cosine 2x plus 2 is equal to this over here. Okay? So the first thing, I'll be working on the left side here. So basically, the first thing I'm going to do is I'm going to use the change of base formula because I noticed that this is in a base 9 and we're trying to end up with a base 3. So that's kind of a hint that, okay, I want to use change of base so I can change the bases. So I'm going to rewrite this right here on the left as log base 3 of cosine 2x plus 2 divided by log base 3 of 9. Now log base 3 of 9, we know this is equal to 2, right? This is equal to 2 right here. So basically, if this is 2 on the bottom, I can rewrite this as 1/2, right? Log base 3 of cosine 2x plus 2, okay? Because this right here, we know this is equal to 2, so if you imagine there's a 1 right here, so basically you have 1 over 2, that's where this 1 over 2 comes from, okay? Now, using our logarithm properties, we know if we have a coefficient in front of the log, we can take this and we can move it to the back here, and it would become the exponent of this right here, right? So since we have log base 3 of cosine 2x plus 2 to the 1/2 power, and we know something to the 1/2 power is really just a square root. So the square root of cosine 2x plus 2, right? And that's, I believe, what we were trying to show, okay, up here. All right, so that's part A. All right, so let's take a look at part B. So part B, you need to solve this equation, okay? Now we know that log base 9 of cosine 2x plus 2, which is this, is equivalent to this, right? So I can substitute this with this right here, right? So let's set that up. We have log base 3, right, of 2 sine x is equal to log base 3 of square root cosine 2x plus 2, okay? And since we have log base 3 and log base 3 here, we know these values have to be equal, so we can equate them. So we know that 2 sine x has to equal root cosine 2x plus 2. Okay, so we've got our trig equation set up, so now we need to solve this. Okay, and remember our interval is from 0 to pi over 2. So we'll keep that in mind when we find our solutions later. Okay, so from here, the first thing I would do is I would square both sides. So if I square both sides, right, that's going to give me 4 sine squared x is equal to, and then this will leave me with cosine 2x plus 2. Okay, so now the next thing I realize is, well, I have this cosine 2x here, right? So I have this cosine 2x. So cosine 2x, I can substitute it with one of the cosine double angles. All right. Now, since this is in terms of sine right here, I know I'm probably going to replace it with something that has the sine value. Okay. So I have 4 sine squared x here is equal to, so this would be, I believe we have 1 minus 2 sine squared x. Right, so I'm replacing this cosine double angle with this right here, plus 2. And then we can add this to both sides. We have like terms. That would give us 6 sine squared x is equal to 3. Divide by 6, so we get sine squared x is equal to 3 over 6, which is 1 over 2. And then we're going to square root both sides, all right? So then we're going to end up with x is equal to, so we have a plus and a minus. So the square root of 1 over 2, right, that would be 1 over root 2. And when you rationalize this, this is going to give us plus or minus root 2 over 2. So go to unit circle, we have right here, all right, root 2 over 2, we know that's pi over 4, okay? Now, our interval, I believe, was only up to pi over 2, so we only care about the first quadrant. So yeah, our interval was from 0 to pi over 2 for x, so we're only taking values from the first quadrant, okay? So x is going to equal, all right, pi over 4, okay?